Hey everybody, this is Larry. This is August 9th day of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Hope you have a great Monday. Today's problem is add strings. I hope today's problem is a little bit easier than yesterday's because it took a while and I don't know, I want to do other stuff. Anyway, given to a string, return the sum of them as Okay, so I usually solve these live, so yeah, if it's a little bit slow or a little bit long, just fast forward, watch it on 2x, whatever you need to do. So this is actually an interesting problem. Obviously in Python, especially in Python, but even in Java, you have big int and other languages have libraries that allow you to do this, without thinking, right? And I would say that, what would I say? So I would say that it's kind of funny because about when I first started programming, or when I first started competitive programming, maybe like about like 18, 19 years ago, something like that, 20 years ago. So when I did that, many of libraries did not have big int. I think Java was at 1.3 or 1.4 at the time, or at least like, and the judges were a couple of versions behind anyway. So I don't think it had big int, or at least it wasn't performing, or something like that. There's something weird about it that I remember that. And just many judges didn't even have Java. And C++ didn't even have, good support. So everyone, all the competitive programmers would have their own library, and some of them traded code, or like share knowledge, not like like a trading card, but share knowledge on it, because back then people just also didn't publish the libraries because there was a competitive advantage, I guess, because back then it was more about, well, depending on who which judge and stuff like that, but there was about life saving, which you may be familiar with, but some people were also about just getting the most number of problems, and sharing their code means that other people would have more problems as well. So that's a little bit weird there. And anyway, big int was a big library that for some reason people just really like giving up problems on, and some problems when you see it, you're like, oh, this is a dumb problem, this is an easy problem, except for that it requires implementing big int, which means that either you have a library or you just have to spend an afternoon or 2 or 3 implementing big int, because also the resources were not as good back then. But that said, all the functions are pretty straightforward-ish, adding, multiplying, and subtracting, and so forth. I think there's a divide and conquer one for multiplying, which you can read about or Google on if you're interested about. But the schoolyard way of doing things generally works, which means that for addition, you just kind of lining up digit by digit, and then one at a time, just adding it, calculating the carry, and then just like you would do on paper. There are no tricks about it. It's just implementation, straight and through. Nowadays, kind of got into a little bit of a storytelling mode here. But nowadays, of course, there are a couple of things. One is that most libraries already do it, or most languages have libraries that do it, or in Python's case, it just does it automatically. And two, these are not that interesting as a problem, though maybe for interviews, you might want to know them for your sake. And for competitive, especially now, this is why you actually see a lot of problems have like, okay, let's just have this mod thing that you can mod so that you can still solve the problem without implementing big int, which is why sometimes I complain about people using mod in problems that in a way that focuses on the wrong thing, because when you solve a problem, people recognize things. Just be particular about who what kind of problem you want to set. Anyway, all right, story time is a little bit long today. Kind of goes back a little bit, but today let's just implement this, right? And there are a couple of ways to do it. You can you could convert it to an array and then do it off by one by one. The way that I'm going, you will have to kind of so in some languages you can do them in place, and if you do them in place, you could save some space, which is kind of nice. And in some, but yeah, but in Python, that's not one of them. So it is what it is. I know that I actually do not like in-place algorithms in general, or not that I don't like them, is that in general, it doesn't really make sense because your inputs and your outputs, have a side effect that you do not, if you're calling that API, you might not like that the API has a side effect that you're like, why is this doing this to my data, right? So I generally am not a fan of it unless the API makes sense. I think for addition, it kind of makes sense if you do like a plus equal thing or something like that. So, I'm not usually as complaining about that. But all that said, hope you enjoyed the little chat. But let's get started on implementing it. And as I said, because this should be a straightforward problem in theory. But of course, you probably want to, it's an implementation problem. Maybe play it on paper if you need to, just to make sure. And here, you could definitely make mistakes because you want to add from the least significant digits first. In my case, I'm going to be a little bit lazier, and because you could definitely do it in one pass. I think you can challenge yourself to do it in one pass. Maybe I will do it in one pass. Okay, let's do it in one pass then. But the key thing is that let's do it in one pass because I think it should be straightforward too. So yeah, okay. So so the tricky thing about this is that if you want to do it in one pass, you can't do something like reverse the array or something like that because you have to be just careful about the indexes. And the indexes are not that bad. It's just that it's easy to get wrong or easy to have off by one or something like that. Oops. As I said that I have a typo. So yeah. So So what I'm thinking right now is that I would have to add to the prefix the entire time, or reverse later. So that doesn't make sense. So let's use a deck so we can add stuff to the front. This is a lot, to be honest, a little bit weird. You can actually also just maybe to make it cleaner, have a thing of space of n plus m plus 1 or something like that, and then maybe add a prefix 1 later on, but maybe that also violates how you think about passes. I would also say that in general, passes don't really matter because computers are very fast these days. But and the reason why you want to have it in as few passes as possible in the past is that in the past there is, well, even now I guess, but it's just that it's not as dramatic as a reason. But it's that when you look at, if you're given an array and you look at all the elements next to each other and you kind of go through from left to right, or in this case right to left, but should still have the same thing, is that when you load everything in memory, you're able to kind of go, into adjacent things, adjacent blocks, and not being jumped around. And what that means is that there are cache hits because then now you're looking at the same. There's memory locality stuff. But nowadays, of course, computers are fast. Cache is huge, so you never. I mean, for reasonable size inputs, it's not going to even touch the disk or something like that. Everything is in the L1, L2 cache, so things are fast. But that's why that's the genesis of why people care about passes that much back in the day, which is why I complain about it when there are problems about like, oh, one pass on a linked list. Well, the linked list memory is all over the place anyway. So unless you are very careful about it, but in that case, you might as well use an array. So in that case, passes don't make sense. But in this case, maybe you can make an argument, and I'm going to play around with that. But this is, of course, all just for upsolving, to be frank. There's no, it doesn't really matter either way. But now we have the ditch carry. The current is equal to num1 I plus num2 j. Of course, we have to convert this to int first. And this is, like I said, right? Oh, this is this plus carry because it's equal to current divided by 10 and current mods 10. And then now we append left on current, and then we keep going on. So then now, while this is greater than 0, we just do current is equal to do. Basically, this just replaces this with 0. You can probably write it in a more clever way. I'm a little bit... and you can probably make some optimizations here on the basis that it's not necessary. But I usually write it this way so that I don't have to think about the edge cases. So that is why. And yeah, okay. Yeah, maybe you can put this into one thing. Because this now looks a little yucky, but that's okay. And then just join events, and that's pretty much it. There are a couple of test cases that I always think about when I do a big int, and some of this is, to be frank, well, okay, this is going to time limit exceed because I forget to subtract to iterate. Some of the reason is because I'm used to writing this in C++, and C++ I would use a for loop here instead. I don't like using a for loop where, because you can do it where the variables keep their value over it, but I don't know, it's a little bit of a mess. So yeah, anyway, but hopefully this should resolve it. Expect the string. Oh, this is, we added int. Okay. Okay, so these are all ints. So so then we have to add. Okay, so in theory I could just do a for loop to convert this into strings, but of course the reason why we did it in this funky way is to have it one pass. So I guess we'll just do it this way so that we can keep it in one pass. Oops. And I forgot what I was going to say. That's okay. Oh, okay. That's a silly mistake. And this is why we test things, but yeah. Oh yeah, the thing is that, so I have like a set of mental test cases that I have already, and some of that is just from years of experience, so definitely practice that. 0 is the big one, but also obviously carries, something like that. Yeah, there may be more, but I think these are the, at least to get us started. Yeah, and that looks good. So let's see. So there are no negative numbers. I just want to make sure, because I definitely have made that mistake before. And yeah. Actually surprised that this works. Because there is always like a concern about leading zeros and stuff like that. So yeah, okay, let's give it a submit. Let's hope it's good. Let's hope I'm not too sloppy. And yeah. So what's the algorithm here? Well, what's the complexity? Well, we look at each character in both num1 and num2 so it's going to be linear time, n plus m. And in terms of space, it's also max of n or m. Even though I guess it's the other case as well, but of course, notation-wise, it's also O of n plus m, so it's going to be O of n plus m's time and O of n plus m space. That's all I have for this one. Hopefully the story time is a little bit interesting to you. Maybe not, but otherwise, this is pretty straightforward anyway. Anyway, that's all I have for this one. I hope y'all have a great week. Happy Monday, even though people could say they're kind of annoying, but maybe I'm annoying anyway. But yeah, stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.